Okay, everyone, let's quickly deal with this. First of all, we want to look at question 9, what again? 9C. So we're going to project that. Okay, that's 9C. This function has domain, can we see this? This function has domain of that and range of that. We're interested in the domain and range of this. So one way to look at it is to look at the transformation, what happened from the normal f to this. So can somebody tell me what happened to this in their sequential order? What happened to f of x to become that? Speak louder, please. You have to speak louder. I don't want to have to shout for you to speak louder. Thank you. Yes? Vertically dilated. Okay. Of silk factor 1/3. So the first thing that happened is this, because if this was the last thing that happened, it should have affected everything. So this must have been the first thing that happened. So she's right about that. The first thing that happened was the vertical dilation. So f of x becomes, three things happen, right? So this space should be enough. F of x becomes 1/3 f of x. She's right. So what's the next thing that happened? So this is vertical stretch, scale factor 1/3. Yes, what happened next? Come on, please don't write, we don't have time to waste. Please don't write, thank you. Yes, what's the next thing?
Translate to 5.
Then it was translated. If it was translated 5 units this way and 4 units up. Understand? After the translation, then the horizontal stretch or scale factor 1/2. Now, if it was translated, if it was horizontally stretched before the translation, this is what would have happened. It would have been 1/3 f of 2x first, and the next will have been 1/3 f of, this x is being moved, so it's going to be 2 bracket x minus, because this happened first. But this time around, it doesn't look like it. Okay? So this happened first. So the next thing is your translation. 1/3 f of, so the internal point minus 5, then plus, yes. Wait, did I miss something?
Translation.
Yeah. Oh, yeah. This was a maybe situation. Yes. So translation, we have x minus 5 plus 4. Then after the translation, then you have your horizontal stretch. Wait.
Yes.
Was that what I said?
Yeah.
Yeah. After that, then the horizontal stretch. Uh-oh. Are you sure?
Is this the theoretical
No,
situation
no, no.
or the...
Now the, yeah. 2x minus 5 plus 4. Let's see. Vertical. What happened from here to here? Translation, then the horizontal. Okay. I'm wondering why R2 is not affecting everything based on this order.
It only adds on x to that.
What happened to your horizontal translation? In your horizontal stretch, In your horizontal stretch, let's stretch this function horizontally. In the horizontal, maybe by a scale factor of 2. So let's say I don't know where the x-axis is. So if the x-axis is here, so let's say something like this. So what do we notice here? So if this was the original function, and then the horizontal dilation of scale factor 1/2 is this, it affects the x, isn't it? But it doesn't affect the y. Yes, then we are right.
Yes.
So if it affects the x, it only affects the argument here. Okay? So it's not going to be like everything as a whole. It affects only the x, it doesn't affect the y. So this is right. So I think what I said earlier was a bit confusing. Sorry about that. But if it was the other way around, if we had to stretch before we move it, what happens? If we have to stretch first, so we have like a 2x, then we have to subtract. So if you are subtracting in that case, so you have a 2x. Okay? This time around, if you are not subtracting, so the subtraction is on the point, isn't it? So your point is being, whatever point is being doubled. Then the bracket comes in. So this is the right order of what we should have. And this will help you in determining your domain and range. Why is that? Because you have to consider what happens at each point before getting to the final transformation. Okay? Now, what are we talking about here? Let's look at the domain. The domain of f is every point from 1 and above, right? Here, does it change the domain? Does the domain change? No, it doesn't. It's only the output that changes. Right? It doesn't affect. So imagine if f is, let's try to find a function that is like that. So maybe x minus 1, square root of x minus 1, positive. Okay? If I end up dividing this by 2, does it change the fact that my x cannot be less than 1? No. Okay, so the domain here remains the same. What about here? Because the point that must be here must be greater than 1, it means here, whatever this bracket is, must be greater than 1. The point, the argument that must be taken by that x and that f must act upon must be from 1 and above. If x is acting on a binomial, that binomial must be from 1 and above. Am I making sense? Which means the domain, now we know the domain of f, okay. Since f of x, since domain, yeah, let's put it that way. Since domain of f itself is set of x such that x is greater than or equal to 1, it implies that the domain of, maybe I call this f1, f2, f3, was this called g? Yes, so this is g. So we don't need to call it f3. Then the domain of f1 will be set of x such that x is still greater than or equal to 1. Do you agree? The domain of f2, set of x such that x is greater than or equal to 6. Is that understood? Because everything here must be greater than or equal to 1. Similarly here, what happens? So, therefore, the domain of G is what? Set of x such that, yes? X greater than or equal to what? 3. Does that make sense? Similarly, the range. Range of f, we know, is every y such that -2 less than or equal to y less than 5. Now, what would be the range of f1? So range of f1 whatever f produces, it's 1/3 of it. Okay? So 1/3 of this boundary. That was what? Y such that -2/3. Do you get my point? Less than y less than 5/3. Okay? Similarly, in this case, whatever we get, so let's look at the boundary. Let me see how easier that might be for us. Okay. So this, something has happened here apart from the 1/3. Okay. So now, whatever this, the fact that this is now x minus 5 doesn't change the range. Because even this input is from 1 and above. Which means by default, this is still the range. Are you with me? Now, 1/3 is acting on it. Which means by default, this is the range for this alone. But now, for every value you get, 4 is being added to it. Then that is the only change that happens. So which means plus 4 plus 4. Plus 4 means plus 12/3. So this is what? 10/3. This is also 12/3. That gives what? 17/3. Am I making sense? So the range of F2 will be set of y such that 10/3 is less than or equal to y less than 17/3. Am I right? Am I making sense now? And finally, yeah, I don't think this changes too, because even this remains greater than 1. Right? So if this is greater than 1, it still maintain whatever we have said here. So that means the range of our G is still Am I making sense? Any questions? So we can look at 10C similarly. Now these are transformations called TA, TB, and TC respectively. If TC acts first, what happens? So can we have that here? 10C. So what is the function? F of x is square root of x, right? Now if TC acts first, so I'll write this way, f of x. Then from here, TC happens first. And TC means a vertical stretch, right? So we just multiply it by 5. Do you agree? And after that, TB happens to it. What does TB does? A reflection in the y-axis. Which one is the reflection in the y-axis? 5 square root of negative x. Okay? And the next TA happens. What is TA? A translation. So we have what? 5 roots. Would there be a bracket or not? Yeah, right? It does. Whether you have minus x plus 5, or you have, wait, is it no. That's a minus 2, right? So that will be plus 2, or minus into x minus 2.
I think there's a bracket, right?
I'm asking.
Because it only acts on x, it doesn't act on minus x.
Wait, one by one. Yes?
Wait.
I removed the square root.
Yeah.
I'm just dealing with x, so we can put the square root later. Which one do you
Wait,
think?
should you write plus 2 for the second one?
Yeah, because by default, if
No,
you have...
I mean the second one.
Oh, yeah, sorry.
Oh.
Okay, okay, so which one of these two? Second one, first one. Who thinks is the first one? No one. Okay, hallelujah. You're right. Because this is minus of x. There's a shift in the x. So the shift affects this. So whatever happens, that is being negated automatically. So you have your x plus 2 here. Then in the horizontal, what do you have? Plus 3. So this will be the output. Is that called G? No, we just leave it. So in this case, what is the domain? The domain of this will still be the domain of this, agreed? But that won't be the domain of this. So why the domain of this is what? What's the domain of this one? Here, the domain is what? X such that x is greater than or equal to 0, right? Do you agree that is the same domain here? But what about here? It's opposite. Less than or equal to 0. It's opposite. So that when you have 0, it is 0. When you have -1, it becomes positive, then the square root can be found. Does that make sense? So this is simply the domain. I'm just going to write in this rubbish format. You put it properly in your book. X such that x is less than or equal to 0. Something like that. This time around, this is what your less than or equal to 0 affects. So in this case, you are dealing with minus of this bracket plus 2 less than or equal to 0. Okay? Which gives which means x plus 2 greater than or equal to 0. Agree? So x must be greater than or equal to -2. Then that will be the condition in your domain. And the range. The range is trivial. The range here is what? Say that louder. Greater than or equal to 0. Because when x is 0, this is 0 and that's 0. You only get your 5 when x is 1. Of course, don't forget there are also 0 point something value that can be substituted. So 5 is not the first one. 0 is the minimum. Now that 0 is still the minimum here. Agree? But that's not the minimum here. Of course, the square root gives you a minimum of 0. But there's an addition of 3. So what is the range? Greater than or equal to 3. That's the difference. So the range of G, if I call that G, will be set of y such that y is greater than or equal to 3. That's all. Does that make sense?
Yeah.
This is something I want you to do more practice on. When you have different combination of transformations, how does it affect the equation? It can be confusing sometimes. So you need to really do more practice on that and see. Sometimes this is what I will do. I will look at the behavior of the graph online or in my calculator to see how my reasoning can be visualized. That can help you. Okay? So now having said that, the investigation that you did, please look at your laptop while I show you mine also. Let's see. Then we need the middle screen. Is there? Okay. All right. So let's look at now let's look at this. Now, if you plot 1 over x and 1 over, if you plot x and 1 over x, what does anyone notice here? Based on what you have written. Okay, how about we plot 2, then maybe we can do some comparison. So I'm going to plot the last one as well. The last equation is, none of this equation has negative gradient, okay? So I'm going to plot the last one and change the gradient to negative. Instead of having plus 3, we change it to minus 3, all right? So our conclusion is not just on positive gradient. So let's see. So negative 3x plus 4, that's the line. And the inverse of that, negative 3x plus 4. Now, can anybody give me his or her own observation first. I think we can see. Can we also see from there? Is it captured well? Yeah?
It's a little bright, but
Is
I can
it?
see it.
Oh, okay. So once you can capture the middle and it's zoomed, well zoomed. Yes. What does anyone notice here? Two things that I want us to take from here. Yes. What have you written in your investigation? Yes, sir.
The x-intercept is also the vertical asymptote.
That's it. That's one. That's one. What is the other thing? This is about the horizontal asymptote now.
It's y, the y value of the.
It's always y is equal to 0. It's always, sorry, x is equal to 0, the y-axis. Do you know why it is always that? Remember, to get the horizontal asymptote, a rational function is usually written in the form of a mixed fraction. Right? But in this case, it is naturally an improper fraction because you are dealing with a linear function. So you have your ax plus b, and the reciprocal is 1 over ax plus b. There is nothing here. So this is more or less 0, basically. So by the time x tends to infinity, and this fraction converges to 0, everything is y equals to 0 left. Do you get my point? So your horizontal asymptote will always be at y is equal to 0, basically, which is the x-axis. Okay? And your vertical asymptote is always the x-intercept. So if you look at the first one, the x-intercept here is what? Negative 4 over 3? Yes? So if we plot line x equals
Yeah, positive.
Positive.
what?
Because
Positive,
the
positive.
minus 3 cancels it out.
What do you mean?
Not minus.
Oh, it's 4 over 3, it's positive. So,
Positive.
4 over 3, like this? Yes.
Yes.
Look at that. That's where it crosses, and that is the line that this curve never touched. Okay? So if we wish to sketch the graph of an inverse function, a reciprocal, I don't want to call it inverse, you have to, there's difference between the two. Reciprocal is just when you flip it. Inverse means the composition of that function and the so-called inverse must give you what? What kind of function do you get? The composition of a function and an inverse gives what? Say that louder. Stop using your normal voice. Identity function, which is x. Alright? So there's difference. So that's why I'm trying to avoid inverse. You know, it's a primary language. Inverse of 4 is 1 over 4. We have to be careful. This is not inverse, this is reciprocal. Okay, so we need to be very careful with the use of language. So, the first thing we want to do, based on this observation, we only have 15 minutes, I want you to just attend to question 1 of the next activity. Just question 1. Sketch the linear function and use this idea that we have just been discussed to sketch the inverse. Question 1 has 4 of them. So if you could sketch just the first 4, that will be enough. Okay? Just sketch the first 4. I'm sure everyone is able to sketch a linear function easily. Right? You can draw a linear graph. No plotting. It's a sketch, which means you are not using your computer now. Okay? So please, close your computer. Don't type anything, young lady. Do this exercise. Don't waste my time. We only have 15 minutes, and I have something to cover. So don't type on your computer. Close your computer. When I ask you to sketch a linear function, it doesn't mean you draw with your bare hand. You know a linear function is a straight line. Brandy, do I have to keep telling you this? It seems everything I have to always tell you. tell you not to draw with ink. I have to tell you to draw a straight line with a ruler. I don't understand it. So after you do that, try to sketch the inverse. So once you do the first one, I would like to see. Okay? What do you mean? Yeah, if you look at the first one, also. So a line always pass through the curve, the quadrant, where I think that's a very good observation that we should have also written, because that's not obvious. The line, the curve, always passes through the quadrant that the line is also located. Okay, that's a very good observation we should have noticed, we should have mentioned.
Wait, so this is animation.
Yeah, that's it. Are you lost? Don't waste time. So, 2-3 things you need to quickly do. You draw your straight line, you pick the vertical asymptote, you look at the quadrants. Well, maybe not exactly a quadrant because sometimes it doesn't pass through the middle, but I think we understand what the quadrant means in this case. And make sure you have a neatly sketched curve. Some of you will draw your asymptote and it still touches, the curve still touches the line. That doesn't make sense. Alright, go to the next one. It doesn't have to be perfect. Stop wasting time. Things I want to be perfect. What are you doing? You don't need all that. Oh, okay. But you can see the intercept is -1 and your gradient is positive. So when you put x is equal to 0, y is -1. Put y is equal to 0, what is x? That's all you need. Okay? You talking more Chinese? You can try the last one, first one and the last one, to save time. If you have just done the first one, go to the last one. Okay, you're almost done. All right. Go to the last one. Yeah, D. Go to D because it has negative gradients. I want to see what that looks like. So, if you have completed A, go to D. Even if you haven't done B and C. Yeah, if you have completed A, go to D. Because it has negative gradients. So let's see what that looks like. You almost finished. I don't have grade. Okay, yeah, negative gradient. Oh, C also has negative gradient.
That's B.
Is that B?
B.
Oh, okay, I didn't get enough sleep. B has negative gradient, so B or D will suffice. Okay? I just want to see negative gradient, what it looks like. Leo, if you have completed A, go to B or D because they have negative gradient. Thank you. You're still here? You're wasting time. You can label all that later. I want to see the shape of B or D. You're wasting time. You might want to look at that. Even though it's a sketch, but should be meaningful. I can address that later. Complete this quickly. Good job. So, regardless of any number of worksheets that I return back to you today, you don't have to hand in tomorrow, but I expect them by the end of the week. I'm giving them out so we don't have to bother about this area anymore. That's the point. Okay?